Yeah, so now that not the part two, because we just did that. We just talked about that.
Mhm.
But then there's the assignment one. There's assignment called homework, and then there's one called group meeting.
Yeah.
I'm talking about the group meeting. I'm just going to call it what it is.
Okay.
It feels like a quiz, but it's called a group meeting.
Okay. Yeah, I'm ready to go whenever you are.
All right, I'm in. So lesson 4. Am I right?
Yes, that's right.
Okay. Yes, I'm starting now. Okay.
Okay.
So I'll just go ahead and answer the first two. I put true for both. That was supposed to be funny. And I feel like our computer froze. Yeah, your screen is frozen. I'm going to text you. I don't know if you can hear me, but I'm texting you. Oh, you texted me first. Let's see what this says. Yes, your computer froze. I will give you a minute. Okay, I texted you back. I'm going to figure out these questions while it's frozen. I'm going to take a look while you're frozen. I'm talking just in case you can hear me. Okay, question 3. Do not give probability answers as percents. Human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. So, don't give it as a don't give answers as percents. I'm going to add up 0.45 plus 0.40 plus 0.11 plus 0.04 equals 1. So I would say that 3 is true. The blood types, the proportions given in the table are divided probability distribution. So I would say 3 is true. What is the probability that a randomly selected person in the United States has type O blood? And the probability, did you text me? And the probability would be 0.45. What is the probability that a randomly selected person in the United States has type O blood? 0.45. What is the probability that a randomly selected person will not have type O? Let's add up all the others. 0.40 plus 0.11 plus 0.04, 0.55, 0.55 for number 5. Number 6. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle 1 of the dogs demonstrates the identification of a specimen. 7 bowels containing urine were lined up in a random row. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? I really need to write this down. All right. Dogs were trained next to trained to lie down to Mr. Specimen Drive. 7 bowls. Here, I can line up in a random row. 6 of the samples were from patients who did not have bladder cancer. Okay. So, if there's, let's say 1 divided by 6 equals, or, what's the question? What's the total divided by 3?
Okay, I'm back.
Oh, good. I've gotten
sorry.
this 1. Oops. I've been recording this whole time.
Okay.
0.43. And I've answered all the way up to question 6.
Oh, wow. You're awesome.
I
Okay.
just kept going. And they're super easy. So I'll talk you through what I did.
Okay, sounds good.
And then you can tell me. So first 2, 1 I put true, and the second one I put true.
I don't know if those are right. Just kidding.
Stop it. Don't give me a hard time. All right. And then for number 3, I put true, and the reason is that all of the blood types add up to 1, and that would be a probability distribution. I'll let you read through that and then tell me if I got the right answer or not. Yeah, I answered true on 3. I have my notes. I think your computer froze again. Darn, I was hoping we could get there. Alright, I'll just pick up where I left off on the recording and go to number 7. And then we'll have to close out the recording so that we can have our meeting, because it never works when we're recording. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? Let's try that again. What does it say? In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. So 22 out of 54. It's very unlikely the dog would do this by random chance alone. Which of the following statements is most appropriate? I would say that this provides strong evidence that dogs can detect bladder cancer. But 22 times out of 54 doesn't really seem that well. That's a lot of times that they didn't get it. But if it's saying in the actual thing. Are you back?
Yeah, oh gosh, I'm so sorry.
Did you hear 3? I said true for number 3.
No, I didn't.
Is that
I
what you
switched
decided is right?
So this will work. Yes.
Okay.
Yes, I did.
I put true for number 3 because I added up all the and then
Okay.
at the top it says don't give your answers. It says no, to give all your probability answers as decimals. Do not give probability. So number 4,
Okay.
I just put the number in the box for O blood, 0.45.
Okay, that makes sense.
I think I lost you again.
I can hear you.
Put 0.45, I just copied it from there. And then for number 5, I added up all the numbers except for maybe 0.55.
Yeah, that makes sense. Uh-huh. Yeah, that makes sense. So,
and then for number 6, that there's 7 bowls of urine. 6 of those does. So we're trying to find the container that does have cancer or the probably. So I said 1 divided by 7 and got 0.143 after I rounded.
okay, that makes perfect sense. Okay, so number 7.
Look at number 6 because I to make the right thing.
Okay. Okay. So would number 7 be?
So what answer did you get from number 6?
There's little evidence that dogs. Oh no! Oh, I'm sorry. I heard the wrong number. Hang on. Sorry. I got 0.143. Did you hear me?
What number are you on? I heard you ask.
I did number 6, and I got the same answer you did. Okay, can you hear me now?
Okay.
Yeah.
Good.
Okay, for number 7, if you can hear me, I think there's little evidence that dogs can detect bladder cancer. Because it says it is very unlikely that the dog would do this well by random chance alone. Can you hear me?